So what we're going to do is take a system of equations that we're familiar with solving, but we're going to look at it from another perspective using matrices and matrix inverses. Now, something to think about is that we can look at this system as two matrices that are equal to each other. In fact, what I'm going to do is I'm just going to write this so that, 2x, not 25. We have a 2 by 1 on the left, and I'm just going to write one equal sign and a 2 by 1 on the right. Okay, now it turns out that this left-hand side can be written as this. Okay, so in fact, if you were to, and I encourage you to do this on your own, but if you were to multiply this side out, you would get the line just above it. So just trust me for now that we can write that first 2 by 1 as a 2 by 2 and a 2 by 1. Now, the thing to keep in mind is that we actually have a new way of solving this system because the goal is to figure out what this thing is, right? So I'm going to rename a couple things. I'm going to call this matrix A, and I'm going to call this matrix capital X, and I'm going to call this matrix over here B. So we have a system of the form AX equals B. So just kind of keeping in mind what everything is here. So this A is a 2 by 2 matrix, and you notice it's just the coefficients of the variables. This is a 2 by 1, and this is a 2 by 1. So if you think back to matrix multiplication, those dimensions match up, okay? So what I'm going to do is, normally when you try to solve for x, and that is the goal here, we want to divide both sides by a, right? But we can't do that here with matrices because there is no such thing as matrix division. But remember that instead of division, we could multiply by, well, it was the reciprocal in algebra, but here we can think about it as multiplying by the inverse. Because we already know that A inverse times A is the identity matrix, and the identity matrix times another matrix is another matrix, as long as the dimensions allow us to do the multiplication. So I'm going to multiply both sides by A inverse, and I'm going to do it on the left because remember that order matters when we talk about multiplying matrices, right? So I have A inverse times A, which I already know is the identity matrix. And I already also know that the identity matrix times any other matrix is just the matrix. So right away, I have a formula, if I can write this in matrix form, for the solution to the system X, and that's A inverse times B. So in this case, what I'm going to do is I'm going to take this example, and I'm going to solve it using the matrix inverse idea. So we have A equals 4, -3, 2, 5. And I'm going to use the shortcut formula to find the inverse of the matrix, which remember was 1 over, so it was the product of the main diagonal, 4 times 5, minus -3 times 2, times another matrix where we interchange the main diagonal and we flip the signs of the other diagonal. So that looks to me like I have to resimplify. It's 1 over 26 times 5, 3, -2, 4. Now, ordinarily, I would multiply the 126 through, but I'm not going to do that because I'm going to be multiplying this by another matrix, and not having fractions everywhere might make it a little bit simpler. So A inverse B, then, is equal to 1 over 26, 5, 3, -2, 4, and B on the other side was 2 and 40. So I'm going to multiply these two together first, and we know how to do that. So this is 5 times 2 plus 3 times 40. So 5 times 2 plus 3 times 40 looks like 130. And down here we have -2 times 2 plus 4 times 40, which looks like 156. And if we multiply the 1 over 26 in, or basically just divide everything by 26, because that's really what's happening, we get 5, 6. So that means that my solution is x is equal to 5, 6. But remember that x was the matrix xy. Whoops, except, bad habit, always wanted to write that as a fraction, but it's not. This means that x equals 5 and y equals 6, and there's our solution. So there is solving a system with matrices. Not bad, especially considering Gauss-Jordan could have multiple steps if you can't get those numbers to work out. So hopefully this example helps you, and I appreciate you watching, and watch out for more. Thanks so much.